back to example 2 on the other page. This is not the most important lesson you ever had. Here we go. We want to buy a car now. You don't have enough money, so you have to take a loan for $20,000. It's called financing an auto loan. You need to finance that amount, which means you need to take a loan out for that amount. You have some options. You could do 3 years at 2%. You could pay it back in 3 years at 2%. You could pay it back in 4 years at 4%, or 5 years at 6%. So those are your options. Let's go for it. What is your monthly payment? That's kind of an important part of this, is how much do you need to pay a month. So for the first one, we're doing 3 years. So N would be not 3 times 12. Because we are compounding 12 times per year and paying 12 times per year. Next, interest rate for this one was 2%. The present value. So here's how we're going to think of this. Because you took a loan out for $20,000, that's $20,000 in your pocket. You own that $20,000, and then you have to pay the bank. You have to pay until that $20,000 becomes $0. The future value is 0. That we're paying down the loan. This is what it currently is. This is what you currently owe. This is what you want to owe. Present value, future value, and then we're going to solve for the payment. So go ahead and plug that into your calculator, and we've got 36 to $20,000 in our pocket. Future value is 0. I think we're all good here. And we get $572.85. $572.85. So if you pay that, how much are you actually paying? How much do you pay total? $572 times 12 times a month times 3 years, or you could just do times 36. So you got to go plug that in your calculator. 572.85 times 12 times 3. So you end up paying $20,622.6 is what I got for that. Which means the amount that you pay in interest is that excess amount over $20,622. Not bad. So to get a car, you take out $20,000. You end up paying basically $622 in order to take that money out. So that's what the bank makes. That's how the bank makes money. They make money on that interest right there. Next, maybe you can't afford $622. So let's look at the next best option here. 4 years at 4%. So now this changes this to 48. 4 times 12. It's going to change to 4. This will be the same. 0, 12, and 12. So all we're doing is going back into the app here and changing this to 48, changing that to 4, finding our payment. $451.58. $451.58. Maybe you're saying, oh, well, I can afford that. So let's see how much it costs to take a loan out for 4 years. So we're going to take $451.58 times 12 times 4 years. You're paying 12 times a year for 4 years. So $451.58 times 12 times 4. That's what I got for that computation right there. $21,675. Which leaves you paying a interest amount of $1,675. Look at the difference. That's the difference in interest rate. So even though this interest rate was only double 2, right? 4 is only double 2. Look, you're paying way more than double the amount of interest. And again, because that's interest on top of interest on top of interest. And then the last one is, so maybe you still can't afford that amount. So you got to keep going. You got to do more. You get 5 years at 6%. So now change this to 5 times 12. 6%. You're starting at 20,000. You're ending at 0. So now go and change that amount. 60 years. Not 60 years. 60 compounds. 6%. And you're changing that amount right there. 386. 386.66. Now that's even looking, that's way more manageable. So I can pay that off. That's pretty good. I'm going to take the 5-year loan. But let's see how much I'm actually paying. So 386 times 12 times a year times 5 years. I end up 23,199. That's quite a bit of interest. I don't know if I like that. That's how much you're paying in interest for that. Well, that's quite a bit. How's that make you feel? So obviously the best route here is to go for the shortest term, and when you go for the shorter term, you're going to get a smaller interest rate. That's life. That's how it works. Wait till you see the house stuff. It's crazy. You want to buy a house that costs $300,000. All right, that'd get you a pretty nice house around here. $300,000. To be approved for a home mortgage, you need to put a minimum of 10% down. So that's how much you need to save. How much do you need to put down in order to be eligible for the loan amount? 10%. So somehow you got to save up $30,000 to buy that house. You got to have that in the bank. After your minimum down payment, how much are you going to need to finance? So that's the leftover amount. So $300,000 minus $30,000 would be $270,000. That's how much you need to finance. After you have two options for financing. You can do a 30-year mortgage with a 5% APR, which is annual percentage rate. Basically, that's that per annum is the way the IB calls that, PA, per annum. Or you got a 15-year mortgage with a 3% interest rate. So let's look at the difference between these. You can get a 30-year mortgage. So 30-year mortgage, that would be 30 times 12. That's 360 total compounds. Interest rate is 5%. Present value is $270,000. Future value is 0. We want to pay off that amount until it becomes 0 in the future. 12 and 12. The payment is what we're looking for, so plug that in. This is real. This is actually the real life mathematics. 270. All right, you ready for our monthly mortgage payment? $1,449. I'm gonna round it. I'm gonna round the cents. Okay. So let's call that. How much do you pay total? 1,449 times 30 years times 12 times a year, or times 360. That's how much you're paying. So now plug that in your calculator. 1,449 times 30 times 12. 500. Now you can see how the bank makes some money. On this 30-year mortgage, we are paying that amount in interest. Holy cow. We're paying that amount in interest to finance $270,000. You're almost doubling what you're paying. Isn't that crazy? You're almost paying double. That's amazing how that works out. That's the way the world works. Option B. You can do a 15-year mortgage at 3%. Let's look at the difference. So 15 years times 12 is 180. So you're cutting the number of compounds in half, cutting the number of payments in half. The interest rate drops down to a 3%, and that's what will happen when you have a shorter term on your loan. You're still paying off that same amount. You need it to become 0. It feels like it never is going to become 0. Trust me, I have a mortgage. Okay, so 180 at a 3%. And the only thing that changes are these two numbers. That stays the same. So now solve it. And your monthly payment is $1,865. So if you can somehow muster up an extra $400 on your payment every month, and that's not nothing. That's something. It's a lot to do. Let's see how that changes everything. How much do you pay total? So you pay $1,865 for 15 years, 12 times a month. So 1,865 times 15 times 12, or times 180 if you want to do it that way. You end up paying 335,700, which when you subtract, I just realized I made an error on this problem. When you subtract the amount that you financed, that gives you an interest, the amount of interest you pay at $65,700. I need to go fix this. I need to do 521,640. I need to subtract 270,000, not 300,000, because I'm financing this much, not 300,000. My mistake. That turns that into even worse. That's how much you're paying in interest. Holy cow, this is life. So look at the difference. Oh man. If you can afford $400 a month extra, this is how much you pay versus this much, which is this much difference. Look at the difference in interest. Golly, it's just insane. But this is life. So if you can afford a 15-year, you're gonna save a ton of money. Make it happen. Next, the formula for simple interest. This is not compounding. This is just simple. It's called simple interest. You might see this on the IB exam. This is not how the real world works, but you might see it. So all you got to do to get the simple interest is take your amount that your principal, multiply it by the interest rate, and that would be as a decimal. So like 5% equals 0.05 for that, and then n, the number of interest periods, or the number of compounds. Same n as this. And you might run into something like that. Here's a couple examples right here. So this comes from more of an IB sort of question. The other questions were real life. Meryl and Misty each have 5,000 euros to invest. Meryl invests her money in a bank that earns 4.5% simple interest each year. So what that means is you're taking your 5,000 euros, you're multiplying by this amount, and then you do that the number of years that you have. So we're doing 15 years. So calculate who has more money. So for Merle, her amount of money, at least her interest, we can figure out as the capital, which would be $5,000, using the formula. The rate is 0.045, and the what's next? Number of compounds. It's just 15. This is just simple interest. We don't have to do 15 times 12. That's all we're doing. This is way more easier. This is actually linear, not geometric when you do the simple interest. So you end up with that number right there, 3,375. So the interest she gets is 3,375. Seems pretty high, but anyway, she ends up with 8,375 euros. Misty, on the other hand, investor money that pays 4.4% compounded annually. Interesting, compounded annually. That means the compounds per year is 1. You get 1 compound per year. Let's go plug this into the old calculator. We can use our finance app for this one. She's compounding 1 time a year for 15 years. So the total number of compounds is just 15, because it's 1 time a year for 15 years. She gets 4.4%. So lower interest rate. The present value is $5,000 in the bank. So I'm going to make that negative. The payment, she's not paying. She's just putting a lump sum in and she's just leaving it there. We got to go down to compounds per year and keep these the same as payments per year, because technically the $5,000 is paying you interest. It's paying you once a year. So we're going to keep these the same like that. So now we're going to go to future value and solve for that amount. Ooh, that turned into $9,538. That's the power, euros I mean. That is the power of compounding. It's interest on top of interest on top of interest, rather than interest just based off of this. Just in this scenario, it's interest just based off of the 5,000. In this scenario, it's interest based off of interest based off of interest based off of interest. So you're gonna grow quite a bit more, even though it was a lower interest rate. This was 5.4, 4.5. So Misty wins. Good job, Misty. Colin, Ryan, and Kyle. How much time do I got? Oof, I'm gonna run out of time. I think that's as far as we're gonna go. Something to look out for here. 2.6% compounded quarterly. That means compounds per year is 4. And therefore, payments per year is also going to be equal to 4. Let's read through it. Ryan invests compounded monthly. That's normal. And that means compounds per year is 12. And payments per year is 12. Keep these the same. And then Kyle invests compounded annually. So we're going to keep compounds per year at 1 and payments per year also at 1. So as you work through this problem, that's what you're going to end up getting for that. So we're out of time with the video. I'm not going to start a new video. Your homework, you have review set 2A and 2B. It's from a different book though, so I just printed it out. It's on this. Do the odds as you work through that. Solutions are at the end of the document. Bye.